All right, so let's talk about our first order of business with NMR, and that is chemical shift. So NMR describes, or chemical shift describes the position of the peaks on the x-axis. So we're going to have, often we won't even show a y-axis. It's all the x-axis. And the x-axis, the position on the x-axis, is the chemical shift. The units on chemical shift are called ppm, and that's parts per million. But people just say, where is the peak? The peak is at 2 ppm. And so this end, the right-hand side of the axis, is low shift. So, typically it starts out at 0. And then over on the left is high shift. It may go to 10. It may go as high as maybe 15. That'd be pretty high, but it can go that high. So that's kind of our operative range of chemical shifts. Things will fall kind of on a 0 to 10 scale. Now, just as we saw with IR we had wave numbers, and those wave numbers indicated where certain functional groups showed up. As it turns out, the chemical shift values, we have chemical shift values, and they're kind of like wave numbers. The position of our peak in terms of its chemical shift will tell us about the environment of that hydrogen atom, and very often comes down to its functional groups. So, sp3 hybridized CHs. We will see that CHs, and remember we're detecting hydrogen atoms in our NMR spectrum, our CHs, whether that CH is next to a carbon, a nitrogen, or an oxygen, determines the chemical shift. So, hydrogens that appear in the 1 to 2 range means that the hydrogen's on a carbon, which is simply next to other carbons. 2 to 3 is more indicative of a hydrogen that's on a carbon that's next to a nitrogen. And the 3 to 4 range, how do I make this stop moving? There we go. The 3 to 4 range means the hydrogen is on a carbon that's next to oxygen. So we get these kind of typical ranges for our CHs. OHs and NHs can appear, and they're a little more variable, maybe 1 to 5 ppm or 1 to 3 ppm. And note that everything we've shown here is in about the 1 to 5 window. So these tend to be low shift peaks, more to the right of the spectrum. As we start to see alkene hydrogens that are on sp2 hybridized carbons, if it's a regular alkene, it's 5 to 6. If it's a benzene ring type system, that'll show up more between 6.5 to 8. And then there are other special hydrogens. Aldehyde CHs show up almost always just right at 10 ppm. And the hydrogen off of carboxylic acid, these tend to be way high shift, or what some people call them downfield, actually as far as maybe 13 ppm. So you're going to have to memorize these numbers. There's no getting around it. There is some memorization in organic chemistry. I like to minimize it, but we got to memorize those numbers. Let's see at least one example here. This is 3-amino propan 1-ol. Notice that now this, as it turns out, is a solvent peak. We can ignore that. This is actually our CdCl3 peak, or the residual non-deuterated chloroform in our solvent. We can talk about that during lecture. And now we have 5 different types of hydrogens in here. We have the hydrogens on the nitrogen. Oh, not make it 5. We have 2 there. We have a CH2 group, a CH2, a CH2, and 1 hydrogen on the OH. And so these peaks here correspond to these 5 types of hydrogens. Now some of them overlap. But this CH2 that's next to an oxygen, this is a CH, which has an oxygen next door. These ought to be in the 3 to 4 ppm range. And what do you know? They're 3 to 4. They're about little over 3.5. These 2 hydrogens are, the CH2 is CH next to a nitrogen, and they ought to be in the 3 to 4 window. They are. They're right here in our 3 to 4 window. So this is how we look at these spectrums. Where they show up determines what our peak is. This CH2 is flanked by just regular carbon, so it's in the 1 to 2 region. Works really well. So these are where these peaks show up. So where they are on the x-axis corresponds to the environment around that hydrogen. Let's see another quick example, a little more distinctive. So notice now we're seeing, here's a molecule where we have peaks that are showing up more on the left-hand side of the spectrum. We can go back. These are all sp3 CHs, and they show up a little bit more on the right. Over here, we have our benzene ring with hydrogens. These show up more on the left. So I said aldehydes normally show up at 10 ppm. Bam, right on the money, 10 ppm. These are on these hydrogens on a benzene ring. We said between 6.5 and 8 ppm. It's exactly where they are in this 6.5 to 8 window. And now here's a CH3. That's simply CH is attached to a carbon attached to another carbon. So that ought to show up in about 1 to 2 ppm. And this is a little bit fancier than a typical proton. It's on a benzene ring, but you know, it's around 2.5-ish. That's not too bad. Call that 2.4 ppm. So that's roughly where it ought to be. So where peaks show up determine what they're coming off of, what kind of carbons or oxygens or nitrogens they are attached to. It's the idea of chemical shift.